Hello and welcome to PATINS Live TV. This is episode 29, and today we're going to be having a vendor presentation. And as I mentioned earlier in the season, we use the first Tuesday of the month for presentations that the PATINS staff thinks would be helpful for our audience to have information on. And then the third Tuesday has been a vendor presentation. And today I have Jim Kjendalen from LaZee Tek, who's going to talk a little bit about the products that he has. So Jim, tell me a little about LaZee Tek. I like the name, and I know it means something.
Well, LaZee Tek develops, sells, and manufactures alternative mice, adaptive computer mice for folks with physical limitations.
Very good.
We kind of came around the name of LaZee Tek as they work off of tiny tilt sensors that kind of measure azimuth and elevation. Okay. And we took those words and played anagrams and came up with LaZee. Sounds good.
Sounds good.
Real technical process.
Well, and that's part of it. It's a good name and catchy name as well. So, what kind of products do you have then, as far as in your product line?
Well, we have two main product lines of adaptive mice. We have what we call the original product was the LaZee Mouse. It's a completely self-contained model. Mm-hmm. And then we have the eeZee Mouse, which is a little more recent, and it splits up the physical aspects of it so that the person only has to wear a tiny body sensor instead of the complete unit.
Okay. And you have an example of that tilt sensor. If we could take just a kind of peek as to what we're referring to when we're looking at a tilt sensor.
Yeah, the tilt sensor is basically the old-fashioned bubble level, except in an electronic format. So it measures left, right, forward and backward movements, and all this functionality is built into a tiny IC.
And we're going to take a look at that here in just a little bit, aren't we?
Yeah.
Very good. If you'd like to, give us an example of just how this works. Now, what you're planning on doing is actually controlling the mouse using head tilt process, is what I understand. Is that pretty much it?
Yeah, it can be a head tilt or any other portion of the body. Head, foot, toe, finger, just.
So we go beyond just the head tilt then?
Right.
Very good. Okay. Well, if we could have an example of just how that works. Now, you were talking about maybe doing you've got three products.
Mm-hmm. Yeah, each of the product families each of the two product families have three models. What we're going to start with is the LaZee Mouse family, and we're going to start with the LaZee Mouse Pro. So we'll grab a cable for that.
Okay. Now, these run off USB connections, or?
Yes, they do. They get all their signals from the USB, including the power. So there's no other cables to fight with or tangle up. We'll start by plugging the cable into the unit. We'll put the unit onto a headset. This particular one is mounted with Velcro. So we just squish it down real good so it's got a stable mount. Plug in the microphone.
Now, do you need a special headset to use that, or can you use variations of the headset for the head mouse?
It's pretty flexible. You can use just about anybody's. We choose this particular one because it's got a wide headband so that there's a better stable mounting surface for the unit. Mm-hmm. And the microphone's pretty decent in it. So we just put it on where you intend to use it, plug in the USB cable.
Now, do you have to load any drivers or anything, or is that something that automatically is detected by you're running Windows?
Mm-hmm. As you're seeing on the screen, it gives you the standard USB interface drivers. This is the first time we've plugged in a unit to this computer. So
okay.
What you've just seen is the first-time users. Typically, you get centered in front of the monitor where you want to comfortably work. You reach up, push the home button. That actually calibrates the sensor to your home position. And from there, it's just a matter of tipping your head. You can go as fast or slow as you like.
So it senses when you go over a targeted area then. I noticed that the cursor goes from an arrow to hands, and that would be how you would select?
You can use it with a click and dwell software.
Okay.
What we're going to use here is the microphone that comes with it. And as you can see while I'm talking here, click. It can be spoken words. Just basically any sound.
Sure.
And you can set the microphone. As you can see, occasionally it's taking my voice and trying to drag an icon. There's a sensitivity up here on the unit that you can set it so your typical voice won't be recognized. And it's only when you, or maybe do a louder voice.
So is there any type of calibration that you have to use in order to make it go faster or slower? Is there a way that you can speed up moving across the screen, up or down, left, right, if you really want to move to the screen a little bit faster?
Yes, there is. The unit itself is proportional, so the farther you tip, the faster it's going to go. And you can change the maximum speed by the Windows settings.
Okay.
Your standard mouse speed settings.
So you're still using some of the built-in settings of the computer itself, but also just by accelerating by moving your head either further to one side, left, right, front, back?
Yes.
Okay.
For new users, we typically recommend that from one side of the screen to the other, maybe 5 seconds. As fast as this is going here, it's really pretty difficult to control. But as I mentioned before, this is the first time this computer has been hooked to one, so I haven't changed any settings ahead of time.
Well, it looks really pretty easy to use. It's just a matter of head tilt.
Basically.
And then you can go off the head and use it in different body parts and so forth. So you don't, and you don't have to have line of vision as well. It could be on a foot if you were able to control your foot and so forth. So
sure.
Okay, great. Wow.
Yeah, that's correct. Some people have a conception that from some of the other systems on the market that this has to be in front of the screen or in front of something, but as you mentioned, there's no line of sight required.
Wow.
It can be completely hidden.
Very good. Now that was the Pro, right?
Yeah, this is the Pro model.
Okay.
The Pro designates that it works from sound through the microphone. The other model, Switch, instead of the microphone input, you would plug in a switch to it.
Okay.
And then we have what we call a cursor model, which is more cost effective for somebody that doesn't need this to do the clicking. They don't have to pay for the clicking functionality.
Okay. And how would they click that? Would that be a manual click then on the keyboard or on another device?
It could be anything that they have external switches, for instance.
Okay.
They could take an old mouse, the roller ball kind, take the ball out, and still use it for the switches if they were able to.
Okay. Right.
Sip and puff switch, any type of, basically any switch on the market.
Wow. Okay. Great. And I didn't know that trick about the mouse, though, taking the ball out and just using it as a regular switch. So that's a good thing to know.
Well, those are getting hard to find these days.
Well, they are getting hard to find. Yeah, most of them are going to optical. So, yeah, great. Anything else that you'd like to show us? Now, the difference between the smaller ones and the larger ones are just size?
Mainly packaging.
Okay.
With the eeZee Mouse, instead of having to wear the entire box, there's just a tiny body sensor that the person would wear.
Okay. Well, we changed it up a little bit and got some more materials out here, and Jim's going to show us other ways that we can use this technology as far as even beyond the head sensor type model. So Jim, what are we going to do with the materials you have out here?
Okay. Well, Jeff, we're going to be using an eeZee Mouse switch. It's comparable to the LaZee Mouse switch, except the packaging is completely different. The eeZee Mouse sensors, or the eeZee Mouse systems, operate off a tiny body sensor, which, if you remember the LaZee Mouse, the user had to wear this entire plastic enclosure. With the eeZee Mouse model, the sensor is all they have to wear. So what we're going to do here is just demonstrate it on a good old-fashioned door spring.
And I'm still amazed at how small that is compared to what you showed earlier with the bubble level.
Sure. Yeah, this is basically just a joystick we've thrown together here. This probably isn't the prettiest, but...
So we should get similar responses to what we got earlier then?
Yeah.
Okay.
Yeah.
Great.
We basically have everything set up where it's going to be used. There's our calibration, so the system knows where it is. And from there, as we tip the sensor forward, backwards, left, right, it's going to move the cursor accordingly.
Mm-hmm.
Now, as you'll notice, the speed's not as fast with this as the LaZee Mouse was.
Mm-hmm.
Because we have a bigger enclosure here, we've been able to do a little better processing on the signal. So it's the user feels a little more smoother than what the LaZee Mouse is. Functional-wise, it still does the same thing. It's just a little better control, a little smoother action. This being a
it's just a simple door spring and a clip, alligator clip. It looks like that you use for the demo.
Yeah, and it can be anything. We've got one in the suitcase there that's basically a chair spring.
Okay.
And a piece of PVC pipe. So anybody that has maybe a sturdier situation, that here we've just plugged in a dual switch, left click, right click opens the typical menus.
Okay. So we can still move it and then make your selection accordingly.
Yeah.
Okay.
And switches, any type of standard switch, sip and puff, you name it, just about anything on the market.
Yeah, I was looking at the back now. There is a dial on this particular one. What does the dial do?
We have what we call a range of motion control.
Okay.
That range of motion lets the user control how sensitive the sensor is. If you change the setting, you have to recalibrate it.
Okay.
But this will show that just very tiny movements now will move the sensor. It's basically about 1 degree of movement.
Sure.
If you have it where it's a maximum range of motion, it's going to take more like 5 or 6 degrees.
So you've got some customizable functioning with that particular part that we really didn't have with the smaller unit.
Right. Now, one thing we can do for the customers is to, if they try out an eeZee Mouse and would really like to use a LaZee Mouse, to let us know what the settings are from the eeZee Mouse they test drove, and we can program that into a LaZee Mouse.
Oh, so if they needed to go faster or slower, or?
It actually programs the range of motion in.
Okay, great, great.
To better match them.
Now you mentioned you have a piece of software too that you wanted to show.
Yeah, we like to show something with a piece of software called One Way by Applied Human Factors.
Okay.
And it basically screens out some of the directions from the cursor controls, so that from the joystick here we get forward, backward, left, right. The one-way program can screen out either up, down, left, right, or any one individual axis.
All right, Jim, you mentioned a software program called One Way, and I see we've added another little component here to see just how that works. So it looks like you've got a dowel rod with some with a base and so forth. And tell me how this will work then with one way.
Okay. What we have here is just a basic mechanical structure that is going to rotate in one axis. We use this just so that it's a little clearer that it can't move left and right. As I'm able to tip this up and down. As you can see, the cursor is moving from left to right. Now, one way it comes into play by ignoring any left-right movements that might be occurring here. For instance, you know, if for whatever reason there was, but it's filtering those out. And it takes what signals that are there, and it makes an XY coordinate on the screen.
Okay.
So, for instance, you move as far as left-right as you want to. A left click occurs, and then the direction changes.
Okay.
So when you get to where you need to go, you click again, and it's activated.
What would happen if I could only push down on it and I didn't have the ability to really push up? And I get all the way to the other side of the screen. How do I get back to the other side?
Well, one of the nice features of one way is it wraps around the screen. So as it gets to the left, you don't have to worry about backing up. It just keeps going.
Very good. And I would imagine it would do the same thing if we're going up and down.
Yes.
It'll go to the top and then, there you go. Okay, great. Well, that's a nice little piece of software. And with the technologies that you've integrated, I can see a lot of potential for really customizing it more for a specific user's needs in order to access things like the computer and so forth.
Yeah, thank you.
Very good. Well, I think that wraps it up. And what I'd like to do is thank Jim for coming today. It's always a pleasure to have new information to share with folks. I do want to remind you one more time that the state conference, the Patin State Conference, is going to be November 4th and 5th. It's here in Indianapolis. It's down at the Crown Plaza with the historic Union Station. And with that said, Jim, again, thank you very much. Appreciate it.
Jeff, thank you.
You're welcome. And we'll say goodbye.